Hi again, everyone. Dr. Tom McNamara here. I wanted to do some extra examples on function composition for you here. Now, you'll remember from our previous video that function composition involves taking one function and putting our input in there, getting the output from that function, and using it as the input to another function. So in this problem, they've given us two functions. This function f computes the number of pints in x quarts, right? So the input is quarts, and the output is pints. X takes quarts, give you pints. And the function g computes the number of quarts in x barrels. So x represents the number of barrels. So for g, you take the number of barrels, put that into the function, and it gives you the number of quarts. And it's asking f of g of x, what does that compute? So the function composition. So remember, the input would go into the function that is closest. It would go in right there. So x goes into g. And what does g take? Well, g takes barrels as its input. So it computes the number of, in x barrels. Barrels would be over there. So the input x is barrels, and let's kind of follow it through here. Number of barrels there goes into g. G gives us the number of quarts. The number of quarts goes into f, and it gives us the number of pints. So the output is the number of pints in barrels, okay? Let's check our answer. Great, we got it. And there was one other one I wanted to show you with function composition. Just so you don't get tripped up. It's this one right here. It says, use the graph to evaluate this expression. And they say f of g of 1. All right, well, we got to go back and think about the very beginning of the course. Having the graph of a function is just as good as having the function's formula. We can read input and output values right off of this picture. So f of g of 1. We have to figure out g of 1 first, right? G of 1. Now, how do you do that? You're using 1 as the input to g. On the graph, the inputs are your x coordinates. The outputs are your y coordinates. So this point right here, you see that? 1, 2, that's on the graph. That means 1 goes in, 2 comes out for the function g. 1 goes in, 2 comes out. Now, what do we do with that 2? Well, we take that 2 and we use it as the input to f, because it's f of g of 1. So we're using 2 as the input to f, because remember, 1 was the input used to g. 1, 2 is on the graph, so g takes in 1, gives us 2. We take the 2 and give it to f, and that gives us negative 1. So negative 1. And then check answer. Great. And similar here, g of f of 1. Okay, well, we just look at the graph of f. 1, negative 2. That means 1 goes in, negative 2 comes out. What does g do with negative 2? Well, g gives us negative 1. Okay, that's unusual. They both gave us negative 1. Usually order matters with function composition, but this was a special case. So the thing I wanted to emphasize, or the thing I wanted to show you in this example, is how to use function composition when you are given a graph. So you can do this stuff if you have the formulas for the function, yeah. And we saw that in our previous video. You can also do function composition if you know the graph, because the graph tells you inputs and outputs just as well as the formula does.